Alright guys, today's goal. The learner will understand what the law of sines is and how to apply it. Okay? Understand the law of sines and how to apply it. Given a over b equals c over d, solve for the given variable. Solve for b. A over b equals c over d. So that means bc equals ad. So that means b equals ad over c. So try that for c now. And we'll check it in a minute. For 3, evaluate the expression. Just make sure your calculator's in degrees and hit 8 times the sine of 32 divided by 5. See what you get. Okay, so it says solve for the sine of x equals 0.2. So this is what you need to do between 0 and 9 degrees. Inverse sine of 0.2. So if we do that, check your mode because I just got radians. I get 11.53. So what is it between 90 and 180? We'll do 180 minus that. It would be approximately 168.46 degrees. Okay? Because here's the thing. If it's 11.53, that's the reference angle. That means there's 11.53 here. So you got to do 180 minus that to get to there. Okay? So there we go. They even did 3 decimals, so. Alright, so what you're learning about, you're deriving the law of sines, solving triangles, angle, angle, side, angle, the ambiguous case, side, side, angle, and applications. And why? The law of sines is powerful extension of the triangle, congruence theorems of Euclidean geometry. Okay? Alright. I don't know why I did this, but these are supposed to be triangles. In triangle ABC with angle ABC opposite sides A, B, and C, respectively the following. So if you have A, B, C, this is side A, this is side B, this is side C. Okay? Alright. So remember, these are supposed to say triangle. Solve triangle ABC given that angle A, 38, angle B is 46, angle inside A is 9. So when it says solve it, it wants everything else. So find that third angle. So 180 minus 38 minus 46. So that's 96 degrees. Now get the other sides. So I would say sine of 38 divided by 9. And actually, here's the thing. What I would do for this is flip it. So you can actually do this. 9 over the sine of 38 degrees equals b divided by the sine of 46. Because here's b, here's c. So, because then you can just multiply by the sine. So you do 9 divided by the sine of 38. Make sure your calculator's in degrees. And then multiply that by the sine of 46. And you would get B equals 10.52. Then find C. So 9 over the sine of 38 equals C over the sine of 96. So 9 divided by the sine of 38 times the sine of 96. So I get C equals 14.54. So there's B, there's C, and there's the angles up here. Okay? There we go. So what I'm saying is sine A over A is also equal to A over sine A, or capital A. Okay? Alright, solving a triangle given two sides and an angle. This is the ambiguous case. So here's the thing, if I draw this, I know that's 30. Here's B. Well, what do we know B is? 6. We don't know C. We know A is 7. So if I go to find angle B first, I do the sine of 30 over 7 equals the sine of B over 6. So I get 6 times the sine of 30 divided by 7 equals the sine of B. How do I get that angle? We got to do the inverse. So it'd be the inverse sine of 6 times the sine of 30 over 7. So second inverse sine of 6 times the sine of 30 degrees divided by 7. I got 25.38 degrees. But couldn't that also be in quadrant 2? So it could be that, or it could be 180 minus that. Think about that. One of the warm-up questions we had. Or it could be, you have to check, because it's possible there could be two triangles, 154.62. But why can't it be that? Well, because if I did 154 plus 30, it'd be 184. There's only 180 degrees, so that, it doesn't work. So we know that angle B, we know the measure of angle B is 25.38. So then do 180 minus 25.38 minus 30. I did 18 instead of 180. So then you know the measure of angle C is 124.62. So there's B and C. Now we just need to find side C. So I would do 7 over the sine of 30 equals C over the sine of 124.62. So 7 divided by the sine of 30 times the sine of 124.62. So I get C is 11.52. So we've now completed the triangle. Okay? You do always need to check, though, whenever you're given two sides and one angle, both angles, because they both might be true. There might be two possible triangles. So there we go. Alright, a road slopes 15 degrees above the horizontal and vertical telephone pole strands beside the road. The angle of elevation of the sun is 65 degrees, and the pole casts a 15-foot shadow downhill along the road. Find the height of the pole. So, we're looking for X. We have that's 65, that's 15. So if this angle is 65 degrees, that means this angle is 65. So I can get that angle C is 65 minus 15. So it's 50 degrees. So I know that's 50 degrees. So what else do we need? We need another angle. And since that's the telephone pole, I know it's not. I know this angle's 90 degrees, and then I also know that's 65. So if I did 180 minus 90 minus 65, that lets me know that's 25. So now I can set up X over the sine of 50 equals 15 over the sine of 25. So 15 divided by the sine of 25 times the sine of 50. X equals 27.18 or 19 feet. Let's see if we're right. They did 27.2, but yep. Okay. We'll see you guys tomorrow, ready to do law of sines.